Hi, this is experiment number 2 for Chemistry 110, separation methods. We'll be performing two separations, one where you get a bunch of M&M candy and you separate the dye colors by paper chromatography. The other one, we take a sand and salt solution and we separate it by filtration. Please do read the introduction on page 28 and 29. Have your tables ready to go, and I'll give you a brief overview of what we're up to. Here is the lecture on how chromatography works. This is a nice image here, and it shows a lot of the moving parts. This is after things are done. You've taken an impure mixture, you've chromatographed it, and it has separated into pure substances, or at least what we hope are pure substances. It consists of taking, in this case, a piece of paper. We call that our stationary phase, the thing that doesn't move. And we spot the mixture on it. We then stick it into the mobile phase, being careful not to bury it in there because it'll just turn the mobile phase red if you have a red M&M. And we allow it to elute. That's elute with an E, meaning that it'll rise up the paper, and as it does, it will separate if things go well. The physical basis for the separation is the adhesion to that stationary phase, which in this case is paper. Once the chromatogram is complete, meaning it's risen up to near the top, give it a mark. And if you've marked the bottom where you spotted it, you should be able to see how far it went up. We call that the RF value, meaning the retention factor. If it went up halfway, that's an RF of 0.5. If it went all the way up with the solvent front and it's right at the top, that is an RF of 1.0. So it's 0 to 1, and you just compare the distance that the solvent moved to the distance that the spot moved. These things are pretty amazing in that we are separating less than a milligram at room temperature, and it can be easily scaled up. Three-dimensional equivalents known as column chromatography do exist. Okay, so for the procedure, which I'm looking at right now, I'd recommend you just run through steps 1 through 10 in the manual, being careful to follow the instructions explicitly. Here's some special notes, however. You're going to be spotting your sample on the chromatogram, on the paper. I think you draw a line through it first to measure your 0 point in pencil, so you don't separate pen colors. And you do it with a capillary tube. You don't have to suck the thing up in any manner. It'll just rise up automatically. But the key to a good separation is to repeatedly spot small amounts right on top of each other. You're shooting for the tiniest spot possible while at the same time being nice and dark. Paper chromatography is fairly limited in terms of its resolution, so don't expect really tight spots. You usually get bands. Be aware that other methods, thin layer chromatography, for example, work really well. We can use a separate tube for each dye so we don't mix our samples. That's capillary tubes. I mentioned that. You can have 2 chromatograms running in each beaker to save a little space. Notice how they're clipped on carefully. We'll be using something similar, and I'll demonstrate it. The thing to be aware of is that don't let it touch the sides of the wall as it's going up, and don't let them touch each other as they're going up, or they tend to band, meaning they tend to slide over to the side or into each other, and they create a real mess. Make sure they're hanging there freely. As I mentioned before, don't have your mixture in the solution itself. Let it rise up and touch it. That way this solvent will stay clear and colorless. You won't be simply dissolving your mixture into the solvent. Once you're done with the capillary tubes, they can go into the glass waste, not the trash. And then wash and dry the boats that you use to dissolve your sample for the next group. The second part of our experiment is gravity filtration. The principle here is that we're taking sand and sugar, and we separate them by their solubility in water. Sand is completely insoluble in water. Salt has a decent amount of solubility in water. By adding water, which is our solvent, it will form a heterogeneous mixture because the sand does not dissolve. You run it through filter paper, that's the gravity filtration. And since the salt has dissolved, it goes into what they call the filtrate. It runs through the filter funnel, and the filter paper drips down as that mixture, and to recover it you simply have to remove the water, making it an effective way to separate things based on their solubility. That's some of the theory behind it. So the solvent in this case is water. The solute is the stuff that got dissolved, which in this case would only be the salt, right? The sand is not really the solute because it didn't dissolve. It's also not completely correct to call the salt, the sand, I should say, the precipitate, because it never went in. Usually a precipitate is something that goes out. But for lack of a better word, we'll probably call it the precipitate. Perhaps it's best to call it the insoluble material. The solution is the homogeneous mixture of salt in water. Okay, so follow steps 1 through 14 in the manual. You'll see an image of a way to run that mixture into the filter paper using a glass stirrer. You could try that if you want. You can try it without it if you want and perform whichever method you find to be better. The usual problem with this is that realize that when you pour this stuff in, not all of it will go in. So I recommend you use a squeeze bottle and squirt around and run it all through. Try not to use tons and tons of water since you have to boil it down. On the other hand, make sure you get it all in there. All the water that goes into here will have to be boiled down, and that can take a while. You'll see a 400 ml beaker and two 150 ml beakers. What's each one for? The 400 ml beaker is for the hot water bath. It's an unusual method to dry things by heating up boiling water, but it works pretty effectively. One of the 150 ml beakers you put chips into, the other one you do not. The one with no chips is for heating and dissolving. The other one you filter into, so it'll be down there. I'll show you how to fold the paper that goes in there. We simply fold it into quarters and open it up so that 3 sides are on one and 1 side's the other. Wet it so it sticks. Pinch an edge if you need to so it doesn't keep opening up. And once you boil this stuff down to recover that which dissolved, be aware that it tends to pop a lot. There's some instructions to help prevent that, but that's always a source of loss. And you're graded on your the percentage that you get. So try not to let that stuff bounce around. Read those instructions carefully. Don't forget those post-lab questions. And I only need 3 and 3 only calculations. 1, the RF value calculation. 2, the percent salt in your mixture. And 3, the percent sand in your mixture. I'm not going to go over those explicitly since I think they're fairly common sense. But while we're running the lab, we can discuss this further. Okay, that is Lab 2, Separation Methods.